Okay, I think the participants have stabilized now, and we can start. My name is Tansen Sen. I'm the director of the Center for Global Asia at NYU Shanghai. I teach Chinese history and Asian interactions here in Shanghai. This is the start of a series of talks on the Mongols. For the Centers for Global Asia, we have centers in NYU in New York and at Abu Dhabi. And together we wanted to do a web series on the Mongols. One reason for that is a course on the Mongols is being taught in Shanghai, and one course is being taught at NYU. It is to give the students taking these courses an opportunity to meet with some of the leading scholars of Mongolian or Mongol history. And our first speaker is perhaps the most eminent scholar who has been writing on the Mongols specifically, but more broadly on China's interactions with the nomadic people. I think many of you know about Professor Nicola Di Cosmo. He wrote one of the most important books on the interactions between the Han Dynasty and the Xiongnus. It is called The Ancient China and Its Enemies, The Rise of Nomadic Powers in East Asian History. It was published in 2002. That gave us a new perspective on the interactions between the Chinese dynasty and the nomadic people, bringing in beyond just the textual sources, archaeological evidence as well, and gave us a perspective, you can say, from the Xiongnu side, which was missing in many of the usual sources. That I would say is perhaps one of the most important books that you have even as of now with regard to China's interactions with its neighboring societies, especially the nomadic people. Professor Di Cosmo has also published a year after that publication, Manchu-Mongol Relations on the Eve of Qing Conquest. It's a different period, but the context is the same. It's the Chinese dynasties interacting with the nomadic people, especially in the north. These two books are two very important books in order to understand these issues. He is a leading scholar of Central Asia as well. He did his PhD from Indiana University. He is currently a Luce professor at the Institute for Advanced Study. And that brings the connection to this seminar and to our center as well, because we are funded by the Henry Luce Foundation, and the lecture series on the Mongols is part of that Luce project that NYU in New York, Abu Dhabi, and we have. So Professor Nicola Di Cosmo will be talking about climate and the Mongol expansion, Mongol conquest. He will talk about around 40 to 50 minutes, perhaps extending a little bit more. For those of you who are interested in asking questions, if you look at the bottom of your screen, you can see a Q&A box. You can put your questions there, and I'll ask the questions on your behalf to Professor Di Cosmo. I'll give priority to the students in New York and Shanghai because they are supposed to write an assignment on the talk. So if the students are asking questions, please in parentheses mention that you are taking a course either in New York or in Shanghai on the Mongols. So without any more of this chat, I'll ask Professor Nicola Di Cosmo to start his presentation. He'll be sharing his screen and he has a PowerPoint presentation. So.
Thank you very much, Professor Sen, for this truly kind introduction. I must say it is an enormous pleasure for me to be virtual, even though only virtually, at NYU Shanghai again. I was there teaching a couple of courses 5 years ago, again on the Mongol conquest. And so we will see what has changed in 5 years in at least my understanding of the Mongol conquest, which derives from several years of work and collaboration with climate scientists trying to understand the importance of ecology, especially when Mongols and other nomads move outside of their sort of comfort zone or ecological habitat and environment. So this is an exercise in joining a new class of data coming from laboratories, from scientific laboratories, for a better understanding not just of the history of the Mongols, although our lecture today will be limited to the Mongols, but more generally on the rise, development, and fall of nomadic empires in, let's say, world history and in Eurasian history, which of course involves also Chinese history. So many questions remain open when we discuss the history of the Mongol Empire. And let me start sharing my screen now so that you can have, is this being shared?
Not yeah. No,
Yes.
it's there. Yeah.
Excellent. Thank you. Thank you. So I'm going to talk today about environmental aspects of the Mongol conquest. First of all, I should start by saying that the Mongols, as you all know very well, are a sort of anomaly in world history and also in the history of nomadic empires, because of the very large territorial extension of their empire, the largest land empire ever built. And even though the Mongols did not rule, generally speaking, more than about a century in each of the areas that they conquered, the consequences of and the legacy of the Mongol conquest were indeed much more lasting and important. So what we have done so far is to, I mean, by we I mean historians, was really to mine the different sources, written sources, for understanding this phenomenon, this very special phenomenon, sources in many different languages, and also to a lesser extent, archaeological sources, material culture, and so forth. What we, however, have not been able to use or even understand to a certain extent is the impact or the importance of climatic changes in the rise and expansion of the Mongols across the many different environmental and ecological zones that they conquered. So in order to do that, we have to understand paleoclimatology. What is paleoclimatology? Is the reconstruction of ancient climates. Before technical instruments could tell us about climate variability, which was about 150 years ago, we need to use other sources to understand ancient climates, other sources that are found in nature, such as ice cores or tree rings or sediments. Of course, historical records are also used by climatologists. Coral, speleothems, that is cave formations, and as in here, all of these elements can found in nature can tell us something about ancient climates. And that's why they are often called natural archives. So when we look at environmental and historical issues in relation to the Mongol Empire, we have to think about several things. First of all, the rise of the Mongol Empire. Is there a reason that might be linked to environmental causes, why the Mongols managed to create their first empire, that is under Genghis Khan in 1206, and then expand very rapidly into by invading northern China and Central Asia in particular. So we will discuss also the Mongol invasion of China and Central Asia, focusing on some recent research of mine, which has not been published yet, but I will show just a couple of cases that highlight the relevance of environmental issues in this, with respect to the invasion of northern China and also Central Asia. Then we will discuss a couple of case studies that were, one of which has been published, and that is the Mongol invasion and retreat or withdrawal from Hungary in 1241. And a very recent study, which is still in progress, that looks at the Mongol invasion of the Middle East, the campaign by Hulagu Khan in 1256 through 1260. That is the invasion of Iraq, Syria, and so forth. And we will look at two key questions. First of all, what is the relationship between climate and the pastoral economy, especially in relation to the rise of the Mongol Empire, and then the environmental and climatic issues that may affect and may condition in some way the military operations of the Mongols, focusing, of course, on the special way of warfare of the Mongols themselves, and that is the special requirements and special characteristics of their army. When we talk about the connection between the environment and pastoral economy, several things need to be said. First of all, rangelands, as they're called, or steppe lands, grasslands, are especially sensitive to climatic changes and climatic variability. These are fairly delicate ecological zones in which even a small variation in terms of temperature or precipitation can have fairly lasting and consequences and considerable impact, therefore, on the human communities that live off that particular kind of economy. When we look at climate, we have to measure the variations in precipitation and temperature, and what are the factors that determine these variations. Some of them can be special factors, that is, for instance, a volcanic eruption that creates anomalous conditions that lower or the temperature or increase precipitation. Now, those variations have an impact on the productivity of the nomads of this particular type of economy. For instance, they might affect the birth rate and the mortality of animals. And different animals, of course, react to these changes in different ways. The nutritional quality of the grasses and other nutrients produced by the land can vary, for instance, and become, for instance, less nutritious, and therefore the carrying capacity, let's say, of the land changes. It supports fewer animals than it would under certain other circumstances. And of course, the water availability and also the quality of the water varies, because we can have more or less salinity, for instance, in the water. So as I said, the carrying capacity, that is, we have to look at the impact of climate onto the territory to assess how many animals and what type of animals a certain territory can carry. And in the case of Mongolia, we have two phenomena that are typically very dangerous for the economy. One is the so-called dzud, which is a winter phenomenon. It's either heavy snowfalls or very, very low temperature that freeze water on the ground. And in both cases, the animals are not able to reach the nutrients beneath the snow cover, which is normally rather light, and therefore they cannot survive under certain circumstances. Droughts have a similar effect. The animals suffer from lack of nutrients, lack of water, and these phenomena are still dangerous today. So if in 1999, 2010, Mongolian livestock was heavily depleted by several cases of this dzud disaster, large percentage of cows and sheep and so on died. Mongolia appealed to the international community for assistance. Now, if we think about similar disasters several hundred years ago, of course, the impact on the population would be devastating. Another aspect that we need to consider is the special requirements of the Mongol army, which is at its core really an army of mounted warriors. The Mongol army, of course, changed in the course of history, adding special troops, let's say, for siege warfare, for instance. But the core of the army remained essentially a light cavalry army where each soldier had several horses. Some people say 5 horses. Some sources refer to as many as 7 or even 9 horses. It's a very self-sufficient army, very resilient army. And its strength lies in the coordination of different army units over a large territory, and also in its mobility. These have been the so-called classic advantages of the Mongol army, those that everybody has stressed over the course of time, and together with a high level of discipline. But as we look at environmental factors and environmental data, I think we will conclude that there is another element that makes the Mongol army especially strong and efficient, and that we will see at the end of this talk. When we look at the relationship between the environment and let's say military operations, we need to look at certain factors. First of all, how many soldiers, how many horses a certain land can support, of course. We also have to look at the quality of the terrain. Is it a plain? Is it a mountain? Different types of terrain can support the army in different ways and offer also different types of advantages or obstacles. But we also need to look at the particular weather. Is it cold? Is it warm? And how this affects then the military operations, the particular targets and objectives of the Mongol army at a particular point in time, and therefore what is especially important is what we call logistics, that is the movement and supply of troops. So environmental data can help us quite a lot to understand better how the Mongol army was organized and how they carried out certain campaigns and certain operations. Now, let me now start to describe my own work, my own investment, let's say, in this field for the past several years, which started with a joint project funded by the National Science Foundation, which was called Pluvials, Droughts, Energetics, and the Mongol Empire. This was my first collaboration with climate scientists. And this study had several objectives. First of all, the study of the role of grassland productivity in the rise and fall of the Mongol Empire. We stopped at the rise, actually. We didn't get into the fall of the Mongol Empire. With spatial attention to explaining the environmental factors, if there were any, that might have contributed to the rise of the Mongols. In that respect, we try to examine the role of water and grass, which both are understood as energy in the success and failure of past societies, of which the Mongols were, of course, one. And in particular, increase our understanding of climate change from the warm medieval climate anomaly to the cold Little Ice Age. Now, these are terms that indicate a certain periodization of climate, let's say worldwide, or at least in the Northern Hemisphere. Climate scientists since the several decades ago, have found some, at the hemispheric level at least, some special phenomena that were generalized, although locally differentiated, which consist in this case of a generally higher temperature during the Middle Ages. And by that, we mean 800 to about 1200 or 1300 CE. And then the Little Ice Age from maybe 1500 to maybe 1800 CE again. These are very general terms, very general definitions that actually do not apply sometimes to local conditions. Now, our results allowed us to propose a different hypothesis in relation to the impact of climate on the rise of the Mongols. The traditional hypothesis that was quite commonly accepted, although never really proved, attributed the rise of the Mongols to a drought that forced the Mongols outside of Mongolia, seeking a better environment for the pastoral economy. One study cited as evidence the ice core data from Greenland that indicated a general drier northern atmosphere in the general period of the Mongol conquest. Now, this was linked, of course, to the medieval warm anomaly, because warmer weather typically produces less water in the system and less precipitation. However, thanks to the study of tree rings and therefore a tree ring based climatic reconstruction, the scientists working in central Mongolia and the Okhon Valley found that there was a period in this reconstruction, long-term reconstruction of Mongolian climate, in which actually there was an increase in precipitation during a generally warm period. The combination of higher precipitation and higher temperature favored grassland production. This is the theory, at least, providing the resources for an increased military buildup, mainly horses, that allowed then the Mongols to engage in extensive military ventures. I will explain this hypothesis in more details later on. The Threering data came from the Ochen Valley, from central Mongolia, which then became later under Genghis Khan, and especially under Ögedei Khan, the political center of the Mongol Empire. This is the article that came out of that particular study. And as I just mentioned, it was found that there was a climate anomaly, that is a higher temperature and higher precipitation in this period, 1210 or 1211. This is it's probably more like 1211. Further studies were conducted in other sites that basically confirmed the same period, a long stretch of about 15 years of increased precipitation. And during this period, that's what we noticed. There was an expansion of the Mongol Empire, not quite an expansion, but anyway, several campaigns into northern China against the Jin dynasty and the Xixia regime, and then against the kingdom of Khwarezm in Central Asia under Genghis Khan, So one hypothesis was that the higher productivity produced by this better climate in Mongolia might have been connected or correlated with increased military activity. This is the full sequence, the full reconstruction. And you can see here in blue the period of greater precipitation. Here 1210 to 1220, well, 1227 possibly, up to 1227. And here it's again a different type of drought reconstruction or precipitation reconstruction, all indicating a higher level of rain and moisture in the system. So this is a common slide that we find all over the web, but it's very useful to visualize the expansion and the many expeditions undertaken by the Mongols in this period, which is quite extraordinary if we think about the population of Mongolia and the kind of resources that they could devote to military activity at this time. So you can see the first expedition started in 1207 and then continued 1209, 1211, 15, 18. In 1218, Genghis Khan goes to Central Asia, coming back in 1225. In other words, it's a very, very intense period of military activity, and this led us to the formulation of a general hypothesis of grassland, so-called grassland high productivity hypothesis, in terms of what this favorable climate on the grassland of Mongolia allowed the Mongols to do. They recovered very quickly from a previous period of intense internal warfare, that is before Genghis Khan in 1206 was accepted as the supreme ruler of all Mongols. That moment was preceded, as I said, by, and as you know, by 30 years of essential civil war within Mongolia. It also ensured a constant supply of horses. Again, the availability of horses is absolutely required by the type of warfare conducted by the Mongols. And without that kind of constant supply of horses that is allowed by a high birth rate and low mortality of horses, it would not have been possible to engage in so many activities, so many expeditions. Also, the high yield of the land probably supported a centralized government created by Genghis Khan himself, where most adult men were engaged in war and military activities, and also to a certain degree increased the agricultural production. This is possible, and recent archaeological discoveries around Karakorum have found also the development of agricultural production in that area with warmer temperature and more water in the system. That might have been possible. So this was our conclusion for the rise of the Mongols. The introduction of climate data tells us at the very least that the Mongols did not leave Mongolia because of droughts. Quite the opposite, they might have created a much more efficient military machine because of the increased productivity favored by warmer climates and also greater precipitation. Moving to the second part of this talk, the Mongols moved outside of out of their ecological zone, as we just said, under Genghis Khan, starting the invasion of China in 1207, 1209, and we need to ask ourselves, how did climatic environmental conditions also favor or hinder or harm the phases of the conquest that saw the Mongols operating outside of their basically outside of the ecology, outside of the grasslands of Mongolia. Some studies seem to maintain that, in fact, more water in the system might have also favored their invasion of northern China and Central Asia, such as the study focusing on the Threering Basin in northwest China, here in published in the Quaternary Science Review. I think there are some problems with this article, but nevertheless, it is an attempt to put together climatic information that applies to the Mongol conquest outside of Mongolia. Now, we have to understand what kind of data we have when we discuss the climate of medieval China, understood in a broad sense, that is including some of the areas outside China itself, such as Central Asia or Mongolia and so on. And this is a general study which was published a few years ago on the type of records that we have. As I mentioned before, these are so-called proxy records, records that tells us something about the past climates. And as you can see, we have quite a few for northern China. We have especially lake records, but also Threering records, peat records, speleothem records, that is cave records, historical records, and so forth. And these records tell us something about the climate of China during the period of the Mongol conquest. Of course, it's not specific enough. We have to look into the sequence and the chronology of this climate reconstruction. More generally speaking, the climate of China is affected by different systems, such as the East Asian summer monsoon, the Indian summer monsoon, the westerlies, and so forth. I will say a little bit more about this soon. So our main concern here is this line, this green line, which is the Asian summer monsoon boundary. This green line, as you can see, constitutes a little bit of a boundary line between two different ecological zones. That is the agricultural zones of China here and the more steppe-like grassland, semi-arid environment of pastoral nomadism in the north. Now, this zone tends to change considerably according to the strength or weakness of the summer monsoon, bringing moisture to this area. And therefore, this boundary can come up or down according to the variations in the strength of the climatic systems that interact in this area. What that means is that grassland can increase or decrease, and agricultural land can increase or decrease according to the moisture and precipitation brought by the East Asian summer monsoon pushed into the more continental areas. So generally speaking, when we talk about the Middle Age, medieval warm period, or several names are given to this period, the Middle Age climate anomaly is another one. What we notice is that, of course, there is a difference between wetter zones and a drier zone. And these are records that indicate in black areas that have an increase in precipitation, and in white, a decrease in precipitation, and the gray areas indicate moderate precipitation, that is average, I would say average precipitation. So all those records that we've seen before, speleothem, stream records, and so on, are translated, let's say, into precipitation records. And this is quite important when we look at the Mongol invasion. If we can take these for actual representation of climatic conditions when the Mongols move into northern China. This is the slides I showed partially before. Let me just say how this works for instance, a lake record. In a lake record, the precipitation is generally inversely correlated to the degree of salinity. So for this particular record, which is a sediment record from Sugan Lake in the Kaidam Basin, which should be somewhere here, on the Tibetan Plateau, we can see a very interesting spike here, exactly at the time of the Mongol invasion around 12, 10, 15, a spike in precipitation, which correlates with a drop in the salinity of the record. But anyway, this is just to illustrate an interesting anomaly in a record that is typically fairly dry, but for the medieval warm period, much more wet and much higher precipitation for the Little Ice Age period. But within that particular dry period, the Mongol period is characterized by an actual considerable increase in precipitation. Now, what I would like to emphasize in the context of the invasion of northern China by the Mongols, by Genghis Khan in the early period of the conquest, is the, I think I need to speed up a little bit here, is the role of Manchuria. The role of Manchuria is very important because it's below that line that I showed you before, let me just, here, it's below this line that I showed you before. And Manchuria, this area in particular, as you can see, is the dark black dots is particularly wet. So as the Mongols moved into northern China, what we find is that they also invaded Manchuria and stayed there, typically to recover from a period of time that it took them to reach Mongolia from their bases, to reach Manchuria and northern China from their bases in Mongolia. They left from three areas in eastern Mongolia, in central and western Mongolia. They reached then this part of northern China, and they stayed in northern China and Manchuria for a while. Why? So the climatic record suggests that this area, which was wetter than the rest of northern China, would have been an excellent place to simply rest and recover after the long march from Mongolia across a mainly very arid and even desertic region. So if we consider that this region is quite dry, is still quite dry, and Manchuria is particularly wet here, then we can see how Manchuria had a very strategic importance on the invasion of northern China as a base that could serve as a launching pad, essentially, for further invasions, and an area that could also provide sufficient nutrition and food to the large cavalry army of the Mongols deployed in the conquest of the Jin dynasty. So the climate record in this case tells us that we have different climates across northern China. In the east, in this case, is much more suitable to grassland production, and therefore it's a good place for the Mongols to rest and relax, I guess, in between military engagements. Moving on to the Mongol campaign in Central Asia, this is a very difficult period from the point of view of climatic history, mostly because we don't have a lot of information. Unlike China, there is much less climatic data that can help us understand the different conditions, let's say, of the various areas invaded by the Mongols in 1219 through 1225. But I would like to look at one case in particular, and that is the case of the Aral Sea. Now, according to historical records, it's quite interesting that the Mongols are usually considered responsible for the destruction of the hydraulic system, very complex human-made hydraulic system of Central Asia in the Middle Ages, which is partly certainly true, and the destruction of dams that, according to historians, contributed to the depletion of the Aral Sea. The Aral Sea, as you know, is mostly desiccated today, and that was the result indeed of human action. But in the recent archaeological investigations have found out that actually at the time of the Mongol conquest, the Aral Sea was as desiccated essentially as it is today, although not because of human action, but simply because of natural conditions that had decreased the amount of water in lakes and rivers at that time, and archaeological field work in this particular area has found, in fact, that there were only the amount of water in the Aral Sea was very, very low. So what we can see from both archaeological and climatological studies is that the Mongols were not responsible, but they were responsible for a lot of things, but not for the desiccation of the Aral Sea. What they were responsible for was probably the reactivation of this area here, the Sarikamish Lake, by diverting part of the Amudarya river into this lake. So they did change certain things, but we cannot assume automatically, as we would from the historical sources, that the Aral Sea desiccation was in the medieval period should be attributed to the Mongols. This was indeed, in fact, the result of about 200 years of warm and dry weather that had driven down the water level in the region in general. So we can draw two partial conclusions as we look at the campaigns of the Mongols into Central Asia and China. First, that the climate analysis shows the strategic importance of the Chinese Northeast, that is Manchuria, and the general zone of the Great Wall in the Mongol invasion of China. That is strategic because they could keep a large number of horses there. And secondly, that the Aral Sea medieval regressions, as we study it from a climatic point of view, changes our notion of how much impact the Mongol invasion had on the local economy of Central Asia. Now, these are very general considerations to a certain degree. We can also deploy climate data for a much more detailed study of several campaigns. And I will mention two quickly. One, this is a published study that some of you may know on the withdrawal from Hungary. As you know, the Mongols invaded Hungary in 1241. This is a general timeline of the conquest. The first battle in what is now Poland, in Legnica or Liegnitz, and then the Battle of Mohi in Hungary. The Mongols conquered essentially the whole of eastern Hungary, and in the winter of 1242, they crossed the Danube, taking advantage of the fact that because of the very, very low temperature, the Danube had frozen over. So they actually rode across the Danube and invaded Western Hungary here. However, the success of the Mongols was far less speedy and far less effective in the western part of Mongolia. And after a short time, a few months, they eventually withdrew back to southern Russia across Serbia and the Carpathians and Bulgaria. So withdrawing therefore from Hungary. So we, by we I mean a climatologist, Ulf Björntgen, and me, looked into possible climatic reasons for this development. And what we found was an anomalous drop in temperature in 1241 from what was a relatively warm 1242. So if you look at this spatial reconstruction of temperature based on various, a combination of various Threering-based chronologies, you can see that in 1241, I mean, the red pink area, it means warmer climate, is replaced in 1242 by a rather colder, the blue meaning cold, climate. And then it starts to be warmer again in 1243. So there is an anomaly, an anomalous, although not particularly large drop in temperature, but still noticeable. And this drop in temperature was in fact responsible for the freezing of the Danube and the invasion of the Mongols into Western Hungary in January 1242. At the same time, there was also an increase in temperature. Here, green means wet, brown means dry. And as you can see again, in Hungary, Central Europe, in 1241 was fairly dry, but 1242 quite wet, actually very wet, and to become dry again in 1243. So again, we have a variation in precipitation, and the combination of a low temperature and high precipitation, what kind of impact does it have on the Mongols? This was the question that we asked ourselves, and this is a general reconstruction of the timeline, and again with lower temperature and higher precipitation, leading somehow to the withdrawal of the Mongols. So in terms of impact, what we found is that indeed the lower temperature allowed for the flows of the Danube, but a higher precipitation meant that there was more water in the system, and a lot of this water actually froze on the ground. As the spring came and warmer temperature, of course, this water thawed, creating more swamps, and also due to the fact that Hungary already has a very high water table and therefore could not be absorbed much. The expansion of swamps and marshlands caused a decrease in pastureland and agricultural production. And the consequences on the Mongol invasion was that on the one hand, this climate variability by allowing the Mongols to cross the Danube facilitated the invasion of Western Hungary. But on the other hand, it also helped the Hungarians protect their static defenses, that is mostly fortified places, compromise the mobility and effectiveness of the Mongol army, because of course the terrain was not what was conducive to swift, fast cavalry operations, decreased access to pasture at a critical time, that is the spring, when the horses need the nutrition most, and compromised also the long-term settlement plans of the Mongols. So this led us to a new hypothesis, that is that the Mongol withdrawal from Hungary was largely affected by the impact of sudden changes in climatic environmental conditions. The carrying capacity indeed is dependent of environmental conditions. This was one of our conclusions. The Threering data that we used were essential information when coupled also with an understanding of the local ecology. For instance, Hungarian hydrogeology, as I mentioned before, the high water table. Then we had to factor in the specific requirements of the Mongol army, that is the ability to move fast on a particular type of terrain. Yes, grassland, but not swamps, not quagmires, not marshlands. And that increased, in fact, that particular environmental change increased the vulnerability of the Mongols, and therefore the effectiveness of their military capacity. So we assumed that, we hypothesized that this was one of the main reasons that persuaded eventually Batu at the head of the army to go back to southern Russia. Oops. The last case I want to mention very quickly is a study in progress. And this is a study I'm particularly excited about, and that is an analysis of Hulagu's invasion of the Middle East, which really started in 1254 with the preparation for the invasion. So I consider those years very important to study the overall planning and execution of the campaign. As you know, Hulagu moved from Mongolia in 1254, reached the northern Iran. There was a campaign against the so-called sect of the assassins in northwestern Iran. In 1258, indeed, as we know, the Mongols took Baghdad in January, and then they moved back to Azerbaijan. Here, they rested for a while, and in 1260, they invaded eastern Syria, northeastern Syria, conquered Aleppo, went down to Damascus. They essentially conquered the whole of Syria. But on the 3rd of September, 1260, they suddenly were defeated by a Mamluk army at the Battle of Angelus. This was an extremely consequential event. For the first time, the Mongols were defeated in a major field battle. The two armies were roughly comparable, about 12,000 warriors, led by one of the most capable commanders of the campaign, Ketbuka, really the right-hand man of Hulagu, while the Mamluk army was led by Kutuz and with some logistical assistance given by the Frankish Kingdom of Jerusalem. So, when we look at, why would we look at climatic aspects when we study this particular battle? Because at the same time, in 1257, in very far away Indonesia, something else was happening that actually affected the whole planet, the whole globe. And that was the most massive eruption, volcanic eruption in the millennium that was recently dated to 1257. This was the eruption of the Samalas volcano. This is a really major event, which, so how does that affect our study of the Mongol conquest of the, or campaign in Syria? Well, the general theory is that this volcanic eruption forces climate to change by lowering temperature and offering more precipitation. This is the general theory. So what might the effect be on the greater Iraq-Syria region? Well, we assume that this has an impact on the land by and on local conditions by offering a longer rainy season, lower temperature, and possibly a reduction in aridity and longer growing season in the period from 1258 to 1260. That is immediately following the eruption. So what this may have caused is an increased productivity of the Syrian steppes and other grassland environments. So one may say, well, that was what favored the Mongol invasion of Syria, maybe. However, we have to consider the fact that most historians considered the withdrawal of most of the Mongol army led by Hulagu from Syria as one of the major causes for the defeat suffered by the Mongols at Angelus. That is, the Mongol soldiers left in Syria were not indeed sufficient to hold Syria against a Mamluk invasion, therefore leading. So why did Hulegu withdraw most of the army from Syria after having taken Aleppo and Damascus? And there are several theories about that: the death of Mongol Khan back in Mongolia, or trouble brewing in the relations, a sort of a civil war that actually erupted later on between Hulegu and Berke, the Khan of the Golden Horde. But there is also an environmental theory, and that is the Syrian environment did not support a very large Mongol army. Also, another theory is that Hulegus miscalculated the number of soldiers needed for the occupation in Syria and did not consider the fact that the Mamluks might attack the Mongols. However, the only source that directly links the withdrawal of most of the Mongol army from Syria was a letter written essentially just after the battle of the defeat suffered at Angelus by Hulegu to the King of France, in which it is specifically mentioned that the Mongol troops retreated because, well, they didn't like the weather, but also they had used up the food and grass in the area, which is fairly understandable when because the estimation of the Mongols that actually moved into Syria was probably in excess of 60,000 Mongol warriors, which meant about 300,000 horses, plus various auxiliary troops. So how do we combine the information that we have about the Samala's climate forcing and climate change with the invasion of Syria and the defeat of the Mongols at Angelus? Well, we assume that the effects of the eruption essentially allowed the area to by area, it means really the northern Syrian steppes, to increase grass production, essentially, and allow, therefore, the Mongols to move into Syria a larger number of troops that would otherwise have been allowed. These very large number of troops and attendant, many horses, quickly exhausted the local resources, forcing the withdrawal from Syria of the majority of the troops. And as I said, this theory fits basically the information that we get from the letter by Hulegu to the King of France. And while I cannot produce climate data because we are still working on this, preliminary data definitely show that we have for the period from 1258 to 1260 a significant climatic change in northern Syria. So the general theory is that the Battle of Angelus was lost by the Mongols because they could not keep sufficient number of horses and soldiers in Syria after the large army brought by Hulegu had exhausted the resources. Such a large army would not have been able to actually invade Syria without the different climatic conditions created for 2 years by the eruption of the volcano in Indonesia. So just to wrap it up now, how does paleoclimatic research change our understanding of the Mongol conquest? Well, we need to differentiate between the initial conditions of the conquest, that is what happens in Mongolia, which I mentioned before, in relation to, for instance, the various geographic zones of Mongolia, the political stability or instability allowed by increased or decreased productivity, and how resources were sustainable over a long period of time, such as horse production, for instance. Then we have to consider how the Mongol army was affected by climatic variability in the successive phases of the conquest. Timothy May speaks of the tsunami strategy. The tsunami strategy means bringing a very, very large number of troops into a given area to reach certain objectives and then withdraw them. But again, the large number of troops that you can bring into a certain area, it has to depend on the resources offered by the area itself, such as Syria, for instance, or Hungary, as we mentioned before. So it's really complicated to calculate what amount of land can support what kind of army to reach what kind of objectives in what kind of time frame. And I think this is, that is, in generally speaking, logistics is really the for me, the most important genius of the Mongols, that is the ability to calculate very, very precisely the relationship between the territory where they were stationed, or which they were invading, their army requirements, what kind of targets and what kind of objectives they were aiming to accomplish, and within what time. So I must say that in the future, I will also probably try to figure out what are the environmental limits of the Mongol conquest, which is something that that we are moving on, but we need more climatic data to. I thank you. I'm sorry I went a little bit over time. I must say in this last slides that we got quite a lot of media attention, which was entirely unexpected when we figure out or we propose something different, something new. And that is because I think there is a, well, first of all, there is a great interest in anything that has to do with the environment, but also because this type of studies in which we bring together history and science, or in particular climate change and historical events, we can, to a certain degree, understand better the relationship between human events and how dependent they can be on even tiny, small climate variability. That is a new approach to historical investigation, and I think is very promising, especially for the study of the Mongol Empire, since we are bringing into this an entirely new set of data, new set of records that might really clarify some questions that have been unanswered for a very long time. So thank you very much.
Thank you, Nicola. That's great, fantastic. I'll come to the last slide you showed with all the publicity you had. But before that, I wanted to mention that you did teach a course at NYU Shanghai, but more than that, you have contributed enormously towards the creation of the Global China Studies program, and you continue to do so. So you are a dear friend of NYU Shanghai as well, and I would like to thank you for that. The second point about the publicity, your article about the withdrawal came out, I think, in 2016, and it did have an impact on how the newspapers and the news media was covering, but it has not been fully incorporated in the textbooks or books on the Mongol conquest. So anything you read, of course, prior to 2016, hardly mentions anything about the climate or weather. There was some issue about pasture or lack of pasture earlier on. Why did the Mongols stop in Hungary? But the connections to climate or weather was not brought up. So I hope this will be integrated into future writings on the Mongols, and it seems to be quite important to understand what happened during the course of a very short period that we are talking about, essentially in the early 13th century to mid 13th century. Um, but that relates in our case, the global Asian studies here that we are doing, to the Indian Ocean as well. You mentioned the volcano in Indonesia. There are a couple of other volcanoes that have a huge impact on the Indian Ocean communications and interactions as well. So it would be nice to link up what's happening on land to what's happening on the Indian Ocean as well, because they are interconnected, the rise and fall of the climate and El Nino phenomena and so forth. We had about 170 people watching you, and the questions are coming. There are three questions. I think they are sort of interconnected, and so I'll try to put them together, and others, if you want to have questions for Professor Nicola Di Cosmo, you can start writing them. So one issue is, did the Mongol know about these climate or weather issues so that they strategized according to it? So were they aware about were they aware about the climatic issues, and so they did their invasions in 1211, for example. So how much of awareness was there among the Mongols as they were doing their strategy? You mentioned that they will use strategy with the number of troops, number of horses, and so forth. Were they also aware of the climate themselves at that time? Do we have any evidence of that? I don't think there are many textual sources about that, but if you can speculate on that. The other question is essentially questioning your use of the data to make the argument. So this is one student asking, are you really data mining to argue what you are arguing? So basically using the information to fit your narrative. So in the case of withdrawal, for example, so this person is asking if it was just a one-off climatic reason not to go into Hungary because of the change in the topography, why didn't they come back after a few years and relaunch an attack on Hungary? And sort of related to that is the question, would there be no Mongol world empire without fluctuations in the weather? And so why does the weather matter so much? And were not the enemies of the Mongols also able to use the weather to launch or defeat the Mongols? So I don't know if this meant together there are three overlapping issues here.
Thank you, Tansen. I'm very happy to be at NYU Shanghai again to give this talk here. Also because, in fact, I did teach that course, as I mentioned. But this is a type of evolving field. That's how I see it. It's an evolving field in which we are trying to put together different types of knowledge. There is a methodological difficulty here. That nobody has really, as far as I can tell, is really managed to work out satisfactorily. That is, how do you put together different data sets from very different production forms of knowledge. Let's say one is a laboratory form where you have an examination of tree rings and lake sediments and so on, which is very much determined by scientific methods. And then there is another data set, which is the historical sources, the sort of reasoning and interpretative reasoning that historians usually do. So there is a methodological frontier here, which is very important to keep in mind. What we are offering are new hypotheses that bring in this new data and essentially produce new questions, more questions than answers, as a matter of fact. So the production of questions is almost as important in historical thinking as the production of answers. But it forces us to do two things. The first one is, what kind of knowledge did the Mongols need in order to plan and execute their campaigns? So I think environmental knowledge is essential for that. I've tried to say this, especially in relation to the campaign to the Middle East by the Mongols, that they needed to know how much food and grass they could rely on while they were moving, for instance, from Uzbekistan today to Iran and into the mountains of Khorasan and to the east of to the west of the Caspian Sea and so on. Each of these movements had to be planned. That's why I think the real genius of the Mongols is logistics. Is understanding and calculating. Now, the planning of the campaigns to the Middle East by Ulegu took 2 years to investigate. Scouts went out to investigate the carrying capacity of the territory through which the Mongols had to go. So I think these campaigns were carefully planned. And so there was quite a lot of knowledge. If we think about Chinggis Khan after 1207, when the mobilization becomes more important and campaigns are planned against China, I think the planning of the campaign had to take into account how many horses they had. They had to count their horses. So if there were enough number of horses, because birth rate was high, mortality was low, that kind of military effort could be sustained. But it's a matter that was calculated for each campaign differently. And I think we should not underestimate the ability of the Mongols exactly to know what kind of food and for how long a certain army needed. That's why I've emphasized the question of Manchuria, which has never been stressed before. In terms of the question of the Mongol withdrawal from Hungary, why didn't the Mongol come back? I mean, we can ask lots of questions like this, counterfactual. Yeah, they're very interesting, but we cannot really answer the counterfactuals. Why something did not happen. I don't think it's an argument to contest, let's say, the reasons why they withdrew from Hungary. They withdrew from Hungary for a certain reason. And among the different reasons that have been proposed, there is now another hypothesis, right? Is added to a series of other reasons. Then we will see. I mean, we will need more data. But we have to consider the fact that for hundreds of years, Hungary was constantly subject to flooding. There is now a flood history of Mongolia written by climatologists that shows that until the Habsburg period, with drainage of the river systems of the Tisza River and other systems, Hungary was subject to periodic flooding. Now, I don't know whether the Mongols realized this or not, but all the nomads that moved throughout history into Hungary didn't do very well, actually. You think about the Huns or the Avars and so on. So maybe the Mongols figured out that Hungary was not the best place for them. But in any case, this is not the point, let's say, of our study. Am I missing something?
Would you say that the Mongol expansion is particularly closely related to the weather?
No, I would say I wouldn't say that. I would say that there are other reasons, but I would say that there are environmental limits to how much the Mongols could expand, and there are environmental events or weather events and climate variability that actually impacts some of the expansion places where the Mongols could go. One of them is indeed Syria. you know, the Syria and the Ilkhans never managed to conquer Syria, you know, after they are expelled by the Mamluks. So that is one area in which, and Hungary could be another one, where and northern India is certainly another one, where the environmental limits for the kind of operations that the Mongols could carry out is reached. Southern China is different. And I can talk about Southern China, but maybe not now.
So thank you, Nicole. There's one set of questions that asks about the sources that perhaps you have with regard to how the Mongols were thinking about the climate or weather issues and then strategizing. So beyond your data that you are looking from the tree rings and other data that you talked about, are there any textual sources that would indicate that the Mongols are discussing, talking about, responding to these kinds of issues?
This is a problem. We don't have sources in. I mean, we don't have sources, many sources from the Mongols in general. You know, until they actually conquer China, then we have a lot more sources about the conquest, or they conquer Iran. Then, of course, we have the Rashid al-Din, we have Juvaini, we have some evidence that that climate might have been in their mind. I mean, there was a small book about weather magic, for instance, in Mongol and Tibetan, in fact, society. But we don't have a lot of evidence, direct evidence or textual evidence that would tell us something like that. We do have indirect evidence, such as the letter I mentioned before. That is a document in which it says, you know, it is our custom to move seasonally according to the weather, and the resources of Syria were exhausted. So we have occasional glimpses but we must also realize that we don't have a lot of sources in general, and that's why the interpretive effort has to go beyond the textual, has to take into account also these other sets of data that enrich our interpretation, in my view. If we just stay with the textual, we are very limited in what we can argue.
So connected to this is my interest, Nicola. We find in many places, India and China, there are all these people who are looking at the skies, the heavens, and talking about or predicting various kinds of weather-related things in the future. Do we see the Mongols also engaging these kinds of people to look at the sky, look at the heavens, and predict what kind of climate they may be encountering
Well,
in either the Persian sources?
In China as well, yes.
Yeah.
Of course. This may be another side of research. It would be very interesting if we could find some kind of astrological or meteorological prediction, predictive ability among the Mongols. This would be more for perhaps for political purposes or ideological purposes rather than actually for the military planning of a campaign. But what we do have is I don't know about that. I cannot say that the Mongols, again, there is very, very little information. If we look at the secret history of the Mongols, which is the source of most of our knowledge about Genghis Khan's period, there is, of course, an element of awe, you know, in terms of what kind of disasters the Mongols are quite scared of large weather events. Could be a tornado, could be a big rainstorm and so on. But they are interpreted in a way that usually explains what has happened before rather than what is going to happen. So, and therefore we need to take them with, of course, a grain of salt. What is important is the knowledge of the shepherd, of the herder. what we know from ethnographic information, and I think this went on forever in a nomadic society, is that herders and shepherds could tell from the variation in the flora and so on what might happen. So there is a certain ability, predictive ability, not at the level of the government or the so-called intellectual class, but perhaps at the level of the single shepherd and the single herder. So that kind of knowledge has been investigated by a number of ethnographers and anthropologists in Mongolia over the past 20 years. And I think that this also gives us a glimpse into how the Mongols could predict or could assess the carrying capacity of the land at a certain time. I don't know if this is clear.
No, that's very clear, Nicola. So there's another set of questions, and I'll ask you two more sets, and that's it. It's almost 10:30. One is you mentioned about the use of Manchuria as, you can say, a base for launching their attacks or expeditions or a place of resting. So the questions are there similar places that they are using as they move west, where they use geographical locations or topographies to come back and rest because they are moving away from Manchuria and going to new places? Do they recreate that kind of a thing to facilitate their expansions as they go further into Eastern Europe?
Well, the other obvious place is the lower Volga region in Russia. So that is where Batu establishes his base and where the Mongols stay then for the duration of the Golden Horde, essentially. So to the east, to the west of the Caspian Sea. So the North Pontic, as they call them, also steppes. This is a classic, nomadic pastoral region where the Mongols stay. So yes, this is another question that we should be investigated in the future, and it's a very important one, and that is, where do the Mongols settle, after the conquest? How do they settle, and what kind of areas do they choose for their economy? I think Manchuria was especially important for military reasons, because they needed to recuperate after this long trek from Mongolia across this arid region. So what environmental data does, I think, this is really in a nutshell, is to focus on some details that otherwise we might lose. So we might not understand why the Mughali went to invade Manchuria if we don't consider also what Manchuria offered to the Mongols at that particular time, and that is a very different environment from Inner Mongolia or even Mongolia in terms of grassland availability.
So Nicola, this is one thing also you mentioned is the possible impact of the Mongols in the aerial sea that people have argued. So the questions are, do we find other examples where the Mongols may have influenced the weather or environment or created adverse situation with the environment during the course of their expansion? So their impact on the environment.
I think both Northern China and Central Asia are the two areas where they are mostly considered to be responsible for the environment. But for the Aral Sea, I should stress, the Mongols were not responsible for the desiccation of the Aral Sea. They were responsible for other things. But in fact, only climatic investigation can tell us whether a certain event is caused by humans, or is just a natural course of climatic forces interacting with the environment. So in that case, actually, we can say that the Aral Sea was not the result, the desiccation was not the result of the Mongol conquest. But the rest of Central Asia was indeed, these two areas, Northern China and Central Asia, but the Mongols learn how to preserve also productive environments later on. So we need to consider different phases of the conquest.
So this final question, Nicola, is going beyond the land and going into the sea a little bit. So the question is, after they experienced the so-called kamikaze, why did they want to go back? Didn't they know there would be typhoons in the East China Sea?
This is like, why didn't they go back to Manchuria, to Hungary? But well,
It's about the knowledge about the climate. I think that's the
of course, there is marine archaeology has found, the Mongol ships that were shipwrecked by the typhoons. And by studying paleo climate, I mean early climatic conditions in Japan, we can see that particular system, it does not occur today. I mean, typhoons do not happen today the way they happened in the 13th century. So the climate system has changed to a certain extent. We don't know whether that particular type of typhoons, the kamikaze, was a one-off thing or was a regular occurrence. If it was understood as just a one-off tragedy, a disaster, then there was no reason why they wouldn't try again. But maybe it was just poor seamanship, I don't know.
Thank you so much, Nicola. I see David Ludden is there. I don't know if he can hear me. He has joined, and if he wants to say thank you from New York. And so, David, there you are. You want to say a few things to thank Nicola?
Yeah. I just wanted to say thank you very much, Nicola. And it's a testimony also to Tansen's creativity, and that he's gotten this thing organized with 170 people joining us from all over the world, basically, in NYU Global Asia program in Shanghai and Abu Dhabi and New York. And it's also a testimony to Nicola's great scholarship and reputation that so many people have come to join him. So it's a really good combination of hard work and successful development of this program. So thank you, Tansen, and thank you, Nicola.
And thank you very much for the invitation. I really enjoyed it.
And thank you, David. I want to thank all of you from all over the world to come and listen to Nicola's talk. As I mentioned, this is the first in a series of talks on the Mongols. The next one is on the 12th, and we'll be circulating the flyers for that. It's on the religious aspects of the Mongols, and we'll end up in December with other talks as well. So we can't join and clap for Nicola here, but we thank you, and you can hear the sounds, Nicola, from all of us. There are still 120 people left, and so thank you again, and we hope to see you back in NYU Shanghai at some point. Thank you very much.
Thank you very much. Thanks everybody for attending.
Thank you. Bye-bye.